Hello class, today we're going to learn how to draw angles in standard position. So, when you first learned about angles, you knew that an angle had to be drawn using two line segments. And the measurement of the angle is the rotation from one line segment to the other line segment. And it was measured in units called degrees. Degrees was given by the symbol of a superscript 0. So for example, you would say that this angle is possibly 40 degrees. So now we're going to learn how to draw an angle on a Cartesian grid. Before, this is a Cartesian grid. We always labeled each part of the grid in terms of quadrants. So we'd always label from the top right that this is our first quadrant. This is our second quadrant. This is our third quadrant. And this is our fourth quadrant. So, considering the fact that this is our first quadrant, we will start over here. Now, because we're talking about angles, we're all talking about the rotation around this, these axes. So we need a starting position. And the starting position, just like the quadrant 1, will start here, on the right. And that's where we start with 0 degrees. If we start from 0 and we move around the quadrants, we're going... So we always measure counterclockwise. So here's 0. So this would be our 9 degrees, 180, 270, and a full rotation will bring us back to 0, and that would be 360 degrees. So we need to draw an angle on this grid. To make an angle, we're going to need two line segments. The first line segment always starts at 0. We call this our initial arm. So this is the first line segment. And to make the angle, we need a second line segment that we can draw anywhere along this grid. So it is an arm that's rotated from the initial arm to the angle in which we're looking for. So let's just draw one over here for now. So we call this second arm the terminal arm because it terminates the angle of rotation from initial to this arm. And the angle that we measure between the two is our principal angle. And it's given by the Greek symbol theta. So the angle that we're drawing is from the initial arm to the terminal arm, and it's written as theta. So there's another angle here that we have to consider, and that's this angle that remains between the terminal arm and the x-axis. So this angle is given the Greek letter beta and is called the related acute angle. So it's related to the principal angle because depending on where the terminal arm ends up, this beta will change. And it's always acute because it's between the terminal arm and 180 degrees. So we think back to our terminal arm, it was a rotation from the initial arm, so beta, if it was over here, would be from this angle to our 0 degrees. Over here, can be anywhere, it can increase and decrease depending on theta. Down here, our beta would be between this purple arm and the 180 degrees. And this quadrant over here, it would be between the arm and the 0 degrees. So, we're talking about trigonometric ratios. So, to make our trigonometric ratios, we need a 9-degree angle. The 90-degree angle triangle is formed by drawing a triangle from the terminal arm to the x-axis, or 0, 180 degrees. So here we have our right angle triangle. We can get our ratios from our beta. So this would be the opposite, this is the adjacent, and this is the hypotenuse. The hypotenuse, in our case, is going to be our radius, because this is our radius arm that rotates around. I'll talk more about this in the next video.